All right, class, this is our last video on section 6.6 in your note packet on the area between two curves. And so we're going to pick up the discussion on page 95 in your note packet with example 4. And so here you're instructed to find the area of the region bounded by the graphs of the equations y equals x squared plus 2x plus 2 and y equals x cubed plus 2. So here you can see in blue is the parabola y equals x squared plus 2x plus 2, and here in green is the graph of the equation y equals x cubed plus 2. So we got to find the area of this region here between the parabola and the equation y equals x cubed plus 2. You can see that the equation x cubed plus 2 is the upper equation, and the parabola y equals x squared plus 2x plus 2 is the lower equation. And you see this area is completely contained inside this square, which has area of 1 square unit. So whatever the value of this area is, it has to be positive, it has to be greater than 0 and be less than 1. Okay? So the two graphs of the two equations intersect at x equals minus 1 and at x equals 0. So a is equal to minus 1 in this case, and b is equal to 0. The upper equation, as I pointed out, is y equals x cubed plus 2. The lower equation is y equals x squared plus 2x plus 2. And when we subtract the upper equation minus the lower equation and simplify, we end up with x cubed minus x squared minus 2x. So the size of this area over here is equal to the definite integral from minus 1 to 0 of x cubed minus x squared minus 2x. The antiderivative of x cubed is 1/4 x times x to the 4th. The antiderivative of minus x squared is minus 1/3 x cubed. And the antiderivative of minus 2x is minus x squared, and the limits of integration are minus 1 and 0. Well, when we put in the upper limit of integration 0 in for x, right, each of these terms is just equal to 0. So we end up with 0 minus 0 minus 0, which we have right here. And then we subtract and put in the lower limit of integration. And again, because there are 3 terms here, right, we got to put those 3 terms inside the parentheses, or we'll only change the sign of the first term and not the second, third term. So when we put in minus 1 for x, we have 1/4 times minus 1 to the 4th power minus 1/3 times minus 1 cubed minus a negative 1 squared. And now this is all arithmetic, right? Got to follow the order of operations, PEMDAS, and when you do that, you should end up with the value of this arithmetic expression is 5/12, and so the area, right, sandwiched between the graph of these two equations is equal to 5/12 square units, which is greater than 0 and less than 1, just like we expected it would be. All right, class, so now let's move on to the example at the bottom of the page, example 5. And we're asked to find the area of the region bounded by the graphs of the equations y equals x to the 4th minus 2x cubed and y equals 0. This is kind of an interesting problem. Here is the graph of the equation y equals x to the 4th minus 2x cubed, right? This is in blue here. And then the equation y equals 0 is that of a horizontal line. And so you can see this green horizontal line is the horizontal line y equals 0, and you notice it coincides with the x-axis. So the x-axis and the horizontal line coincide with one another. So the area that we have to find, sandwiched between the horizontal line and this curve, is right here, right? This area right in here. And the two graphs intersect here at x equals 2 and at x equals 0. Okay, so the horizontal line y equals 0 goes through the origin, and the equation y equals x to the fourth minus 2x cubed. If you put in 0 and for x, you get y is equal to 0. So the graph in blue, right, goes through the origin, and so the horizontal line y equals 0 and the graph intersect at x equals 0. So they intersect at x equals 0 and x equals 2. So a is equal to 0 in this case, and b is equal to 2. Well, finding this area right here, the upper equation is y equals 0, and the lower equation is y equals x to the fourth minus 2x cubed. And so the upper equation minus the lower equation is equal to 2x cubed minus x to the fourth. When you do 0 minus this equation, right, the minus sign just changes the sign of each of these terms, and we go from plus x to the fourth to minus x to the fourth, and minus 2x cubed to plus 2x cubed. So the area bounded by the horizontal line y equals 0 in this curve is equal to the definite integral from 0 to 2 of 2x cubed minus x to the fourth with respect to x. Well, the antiderivative of 2x cubed is 1/2 times x to the fourth, and the antiderivative of minus x to the fourth is minus 1/5 times x to the fifth. And the limits of integration are 0 and 2. So next we got to put in the upper limit of integration 2 in for x, and we have 1/2 times 2 to the fourth minus 1/5 times 2 to the fifth, and then we subtract and put in the lower limit 0 in for x. But when we put in 0 in for x, each of these terms are going to equal 0, and we're just going to end up subtracting 0, which I have not written out. So now we just got to do the arithmetic, right? Evaluate this arithmetic expression following the order of operations, and when you do that, you find the value of that arithmetic expression is 8/5. And so this area here, below the horizontal line y equals 0, and above this curve in blue, is equal to 8/5 square units.